Alright, let's talk about how you name these things. Now that we've talked about how to put them together, let's give them some names. This is your first chance to actually name chemical compounds that you're learning about. So, now, before we begin, let's start off with a quick review. I'm going to start off with an example of, let's assume you've already, well, which you have, you know the energy levels, you know how to assign electrons, and you know that electrons in ionic bonds are given and taken, okay, they're not actually shared. And then you know what kind of ions are formed. So let me give you an example, just to review. First of all is forming ionic compounds. Now, you've done a little bit of work on this, but let's just do a little review. Let's say, for example, here is your cation, and your anion is over here. Alright, and we'll make the cations red. Let's say our cation is lithium. Now, lithium is in group 1, or family 1, therefore it likes to form, because everyone in family 1 likes to form 1 positive ions. Okay, because remember, everybody in family 1 has that extra electron in the outer layer, that energy level that they like to get rid of. So they like to form 1 positive ions. Meanwhile, we'll go blue for anions. Let's say, for example, oxygen, which is in, okay, what we would call group 6 over on the other side, because oxygen has 2 open slots waiting for electrons. It likes to form 2 negative. So it likes to get 2 additional electrons, okay, so that it would form a 2 negative charge ion, okay, because it is in group 6. So here are the cation and anion. If you were to make a compound between the two, how would you do it? Alright, well, I notice that lithium has a 1 positive charge, and oxygen has a 2 minus charge. So how many lithiums would it take to cancel out oxygen's 2 negatives? Remember, to form a stable compound, it has to be neutral. Alright, so in this case, you would need lithium with a positive charge and another lithium with a positive charge. Alright, in order, and if I'm going to rewrite oxygen here. Watch this. Watch how I can rewrite this. I'm going to rewrite it a little way. I'm going to go oxygen with a negative and a negative to show that there are 2 negative charges on oxygen. So notice, if I'm going to bring oxygen over here now, if I have oxygen, we'll put the 2 negative charges here. This positive cancels out, cancels out that negative, and this positive cancels out that negative. Okay, since they've all been canceled out, okay, it's now neutral. But notice it took 2 lithiums to cancel out the charges on oxygen. So at the end of the day, the formula is going to be Li sub 2, okay, to indicate you have 2 lithiums. And how many oxygens did you end up with? Just 1. So the formula would be Li2O, and we would name this lithium oxide. And this is what you want to focus on right here, okay, is the IDE at the end of the name there, okay? Oxide. Oxide means that the IDE means it's the negative one, okay? So let's try one more. Alright, I'm just going to use, let's just use purple, okay? Here is our cation. Let's try calcium. And our anion is going to be fluorine. Alright, well, calcium is in group 2, alright? So that means it likes to form 2 positives. Okay, so the ions that calcium will form will have 2 positive charges. Fluorine is in group 7 on the other side, and because it has only 1 open slot, it likes to get an extra electron and become 1 negative. So it's going to form fluorine ions. Now, by convention, the cations are named just the name of the metal. So this would be called calcium. But again, remember what we did last time. Fluorine has a negative charge. We have a special suffix we put on the end of fluorine. Okay, take a moment to guess. If you said this is going to be fluoride, you are totally correct. Okay, so you don't change the name of the cation, but you do change the name of the anion. All right, now all we have to do is find out, well, how many of each would get together in order to cancel everybody out. So let's bring them into the middle again. So here they come. There are meetings like, oh, fluorine, I love you. Oh, calcium, I love you. And they get together and they say, well, how are we going to work this out? And what's going to have to happen here is we have to have a calcium. We have to have 2 positive charges. And then we say, okay, well, here's the fluorine with its negative charge. All right. And what we see is this negative charge will cancel out one of these positive charges. That's great. But oh my gosh, calcium has another calcium has another positive charge. My gosh, what are we going to have? It looks like we're going to have another fluoride ion. Only with another fluoride ion are you going to be able to zap that other positive charge. Now everyone's been taken care of. Now it's all neutral. Once it's neutral, okay, that's good. I'm golden. I know it's legal, so it looks like it's 1 calcium to 2 fluorines. So how are we going to write this? Okay, and I'm just going to get it right back to purple. It's going to be calcium and then 2 fluorines, so F sub 2. Okay, and again, look at our names. We simply bring down the names. The name of this substance is calcium fluoride. Okay, so this is calcium fluoride. All right. Now again, you started off by using your energy levels to explain why these atoms formed these charges. If you don't know why calcium likes to be 2 positive, okay, or you don't know why fluorine likes to be 1 negative, it would be good to review, but I'll do one page, last slide. Let's switch to blue. All right. I'm just going to show you 2 examples. Let's see, let me just label it here. One for the cation, an example cation, and one for an example anion. Okay, this is just a quick review as to why they like to form these charges. If you're on the left-hand side of the periodic table and you're a metal, chances are you like to form a cation. And here is why. All right, if I am, for example, I'm just going to pick a small one, lithium. Lithium is number 3, so it has 3 protons. I'm not going to worry about the neutrons right now, but we'll just assume it has 3 neutrons. So lithium is element 3. It's got 3 protons. To be a neutral, okay, it would have 3 electrons. But watch what happens. I'm just going to draw the nucleus here. I'm not going to draw all the particles. You know it has 3 protons. Well, I have to fill in 3 electrons. My first little energy level, remember you can put 2 of them in that first little energy level. But now I've only got 1 more electron, and I have to put it in that next energy level because each of that first energy level can only hold 2. So I've got this little electron out here, all right, and it's just sitting there, and it's all lonely. Okay, it's just sitting out there. It's all alone, it's got no partners, it's kind of just out there on its own. Well, now let's switch over to, that's an anion, let's go with like, oh gosh, what should we use here? Okay, so let's go ahead and choose nitrogen. Nitrogen is number, I'll just draw it over here, oops, hello, 7. So again, I'm not going to draw everything in the nucleus, but here's nitrogen. Here's nitrogen's nucleus. And in order to be a neutral atom, we have to have 7 electrons. So again, the first little orbital can only hold 2. And then I remember I can now in the second one, I can fit up to 8, right? Well, but nitrogen only has 7 total electrons, so I've already used 2. How many do I have left to put in there? Only 5. 1, 2, 3, 4, and 5. So if I add up the 5 in the second level plus the 2 in there, I've got my 7 electrons. Notice there are kind of like 3 spaces left over, okay? It's kind of like there's an open space here, an open space here, and an open space here, okay, where these are open. Okay, in order to make a nice happy 8, there are 3 open slots. All right, so in this case, nitrogen would love to gain those electrons. Okay, so nitrogen needs 3 extra electrons. All right, in order to fill up its little happy 8 electron shell. If it gets 3 electrons extra, remember it's not getting any more protons, so it's going to give it a 3 negative charge. So nitrogen likes to form, this is going to mean it will have a 3 negative charge because it got 3 extra electrons. Now look at lithium here. Here's lithium. Lithium's got that lonely electron. If it got rid of that electron, it would have a nice little full first energy level. So again, guys on the left-hand side of the periodic table like to get rid of those extra 1, 2, or 3 electrons that they have floating around in there because it's easier than getting a whole bunch more. If lithium wanted to fill out its outer level there, it'd have to get 7 other electrons. That's really hard. It's much easier to get rid of this 1 extra one. So lithium gets rid of it, okay? And so, lonely gets rid of extra electron. Okay, and because it now has 1 fewer negative charges than it does protons, it becomes, okay, 1 positive charge. Okay, and that's why this happens. So again, this is a review based on the energy levels of making sure that they fill up those energy levels. Once those energy levels are filled appropriately, they are what we would call happy. All right, and this is just one example. If you happen to be on the right-hand side of the periodic table, you tend to want to form negative ions or anions because it's easier for you to fill your energy level by getting a few electrons. If you're on the left-hand side of the periodic table, you're going to be getting rid of a couple of extra electrons because it's much, much easier. And that's the relationship you have between cations and anions and ionic bonding. Okay, so there's your review.